All right, so let's do this TSI math test. The graph shows projected temperatures. We see the y-axis is temperature and the x-axis is time. What's the expected temperature at 3 p.m.? So we're really just going to 3 p.m., moving up to the dot, and then sort of scanning over and seeing that it's at about 22. And so we would choose 22, okay? Let's look at number 2. Here it's telling us the function f of x equals 3.1x plus 240 models total U.S. population in millions, x years after 1980. Use the function to answer this question. What is the total U.S. population in 2011? Round to the nearest million. Okay, let's screen clip this because we're going to need to work with this problem. Okay, let me grab that and let's open up a new notebook and paste this in. Okay. So years since 1980 is going to be important here. It's asking us what the population is in 2011. And X is the number of years after 1980. So first thing we need to do is figure out how many years there are between 2011 and 1980. So what I would do on this problem is the first thing I do is I would take 2011 and subtract 1980 from it. Just like a subtraction problem. Right? So it's 31 years since 1980. So I would then plug in 31 into this equation. So I would do f of 31. So let's go back to our side work and write this out. F of x equals 3.1x plus 240. So we have f of x equals 3.1x, what was it, plus 240? Yeah, plus 240. Okay, and so what we want to evaluate here is f of 31. So that's going to equal 3.1 times 31 plus 240. All right, so we'll just work it out. We need to multiply 3.1 times 31. So it's 3.1 and 31. 1 times 1 is 1. 3 times 1 is 3. 1 times 3 is 3. 3 times 3 is 9. This is 1, 6, and 9. And we're going to put 96.1. So we put the decimal point there. So f of 31 equals 96.1 plus 240. Make that 1 look more like a 1. Okay, so we're just going to add to 240 now. 96.1. So to add a 0.0 there and then do 96.1. We're going to add. So 0 plus 1 is 1. 0 plus 6 is 6. 4 plus 9 is 13. So 336.1. And it's asking us to round to the nearest million. And this is 336.1 million. So we would say that this is about 336 million people. Let's go and see if that's an answer choice. That's what I would pick. I would say it would be 336 million. Okay, let's look at number 3. What are the zeros of the following quadratic equation? 2x squared minus 12x plus 16. Okay, so let's go down here. And let me just double check that I got that right. 2x squared minus 12x plus 16. 2x squared minus 12x plus 16. And I want to actually show the full notation to show why students become confused with problems like this. It's asking us, what are these zeros? Okay. And this language is super confusing. It's specifically this word that students don't understand. And so just forget about this for a second, okay? Forget about the particular problem. All quadratic equations that have what are called real solutions cross the x-axis twice, all right? And the places where they cross, okay, here and here, for example, the x value is some number, but the y value is 0. And here the x value is some other number, and the y value is 0. Because you see here, you've got y 4, 3, 2, 1, and then y is 0 on the x-axis. So they're called zeros because at these points, at these 2 points, the y values are 0, okay? So that's what it means. What are the zeros? Let's get rid of this. We're going to now focus in on another pitfall. So first, we just have to understand what we're being asked, what the words are that we're being given here. The second is, now that I know what I'm trying to find, I'm trying to find the x values of those 2 places where the graph of this will cross the x-axis. Another way of saying this quote, another rephrasing would be, what are the x-intercepts? Okay. Another way of saying this is, what are the solutions? Okay. So the question is, now that I know what I'm trying to find the solutions to this quadratic. How do I do that? And the next point of confusion that many students have is they see this f of x notation here, and they start to wonder, what am I supposed to do with that? Well, what you need to do is just drop that notation completely and set this equal to 0. Okay? So let's set it equal to 0. We're going to rewrite it and set it equal to 0. So we're going to write 2x squared minus 12x plus 16 equals 0. Okay, so now there's yet another hurdle. So we've had 2 hurdles so far, now the third hurdle. How do I solve a quadratic equation when the leading coefficient is other than 1? Okay, so in this case it's 2. And we will try, my first method is to factor by grouping. Okay, so we're going to try this. So if we're going to factor by grouping, the first thing that we need to compute is the master product. The master product is equal to A times C. And so yet another potential pitfall is students may not know what A B and C are. So here it helps to review the standard form of a quadratic equation is ax squared plus bx plus c equals 0. And so you have to look at the locations of these letters and then go find them. So in this case, A goes with the 2, B goes with the negative 12, and C goes with the 16. And I often suggest that students write it down. In this particular example, A is 2, B is negative 12, and C is 16. So what you need to do is A times C. Okay, so we're going to abbreviate master product as MP. And remember that's equal to A times C, which is equal in this problem to 2 times 16, which is equal to 32. Okay, so now I know my master product is 32. And so if I'm going to try simple factoring, what I need to do is I need to find two numbers that add to equal B and multiply to equal the master product. Okay, so remember in this case, B is negative 12. So they need to add to be negative 12. And those same two numbers need to multiply to be 32. And so we encounter another potential pitfall, which is, okay, how do I figure this out? And what I recommend is to just list all the factors of 32, including 1 and 32. And we need these numbers to add to be negative 12. So we know that we need negative numbers, right? Because the sum of 1 and 32 is positive. So we need to do negative 1 and negative 32. So the product of these two numbers is 32. But the sum of these two numbers, we're going to make a little chart here. This one would be negative 33. So because that's not equal to negative 12, we discard this set and we come up with two more factors. Let's try negative 2 and negative 16. So those multiply together to be positive 32. But when I add them, I get negative 18. And that is not equal to negative 12. And so I'm going to discard these as potential factors. So now I think what else multiplies to be 32? And so how about negative 4 and negative 8? That multiplies to be positive 32, but when I add it, I get negative 12, and that is equal to negative 12. So these are my factors, okay? So we're going to go write these in to this little table. Negative 4, negative 8, negative 4, negative 8. Okay, now what we need to do next is split this middle factor up. That's what we are doing, okay? We need to split this middle factor up, and we will split it like this. So instead of writing negative 12x, we're going to write negative 4x and negative 8x. Okay? Because when you add these together, it's negative 12. So I've split this middle term. Okay? And now I'm just going to bring down 2x squared and bring down plus 16. I'm going to bring down the equal sign. I'm going to bring down the 0. Okay? So you see we've got this now. Now we're going to group. So we're going to group the first two terms and group the second two terms. Now, the next step is to factor out the greatest common factor from these terms. And so here I see I can pull out 2x from both of these two terms in this binomial. And it's almost like reverse distribution. We're going to pull these terms out. And so here I can pull out a -8 from both terms. Again, I'm pulling out the terms like this. And so we factored out the greatest common factor here. I have 2x on the outside, open parentheses. These 2's cancel, and I'm just, the x squared divided by x leaves me an x. And then here, the x's cancel, and the 4 and 2 reduce down to just -2. So I have x minus 2. Close parentheses. And then I have -8 sitting out front, open parentheses. And then inside, these -8's cancel, leaving behind x. And then 16 divided by -8 will be -2. So I have a -2 equals 0. Now, these should be the same, and we interpret these as one factor, and then we combine these two to be another factor. So I'm going to write as one of my factors 2x minus 8, and as my second factor x minus 2 equals 0. Okay? So we succeeded. You know, factoring by grouping worked. Now sometimes factoring by grouping doesn't work. In other words, when you're on this stage over here, you can't find integers that work. And so factoring by grouping wouldn't work, and you'd have to do either completing the square or just plug the a, b, and c values into the quadratic equation. But factoring by grouping was successful here. And so we just set each factor equal to 0. 2x minus 8 equals 0. And x minus 2 equals 0. Now I'm going to add 8 to both sides here. And I've got 2x equals 8. And I'm going to divide both sides by 2. And I have x equals 4. Over here I'm going to add 2 to both sides. And I have x equals 2. So the two solutions are 4 and 2. Okay, so those are the two zeros. In other words, I want to make sure that we go tie this back to what was this all about here. What this means is that there exists some graph like this. I don't know what the quadratic looks like, but at x equals 2, there is a point that the graph crosses, and then at x equals 4, there's another point where the graph crosses. So this is 2 and 4. And so what that means is there's some quadratic graph here. I don't know quite what it looks like, but it's going to cross the x-axis at 2, 0 and at 4, 0. And that's why these are called the zeros. And that can be spelled like with the ES or just the OS like that. Okay, I hope that was a helpful kind of tutorial. It's asking us for the volume of a cylinder. Let me grab a picture of this, and then we'll talk about how to find the volume of a cylinder. As we do this, I want to emphasize just how much time I'm spending on each one of these problems. The TSI is traditionally untimed. If you are being given a time limit, then you might have to work a little faster, but typically, these 20 questions should take about 2 hours, maybe 3 hours to do. And so you need to slow down, okay? Slow down, because these problems are deep a lot of times. You need to think about them. So let's talk about the volume of a cylinder. I like to think about a cylinder as two circles, okay, like this, and there's some space between them, all right? So there's some kind of height here, and then typically we have some kind of a radius. And so the way I think about it is, if I can find the area, which would be this shaded region, if I can find the area of the circle on top, then by multiplying that area by the height of the cylinder, I'm basically I'm stacking up all these little areas of these circles. Okay, the height represents like all these circles. I'm stacking them all up, and I'm just sort of adding up all these infinite areas here between the top and the bottom of the cylinder. And so basically we just need to find, let me put it this way, the volume of the cylinder is equal to the area of the circle on top times the height of the cylinder. Okay, so we need to find out, what's the area of a circle? The area of a circle is pi times the radius squared. Okay, so if this is the area of a circle and the volume of a cylinder is just the area of a circle times the height of the cylinder, then let's call height h, right? Then I'm going to do pi times r squared times h. Okay, so it's unclear from this picture, right? But it looks like this little dot here is referring to the height. So I believe the height is 3.5 inches. And this appears to be the radius, right? 2 inches appears to be the radius. The height appears to be 3.5. So let's move down here. We'll write V for volume, and we'll say V, and the little c means volume of a cylinder, is equal to pi times the radius squared. Okay, well, the radius is 2, so we're going to square that, times the height, which is 3.5. So let's just keep working here. We got pi, 2 squared is 4, times 4 times 3.5. When we're doing TSI, we don't have the benefit of a calculator, so I like to convert 3.5 to 3.5, which is 7 over 2. And so I'm going to multiply by 7 over 2, 4 over 1, pi over 1. This gives me 28 pi over 2. And 28 divided by 2 is 14. So this is just 14 times pi. And I don't know if they want us to approximate it or not. Let's go back and look at the answers. Yeah, they want us to approximate it. So we need to approximate pi. So pi is approximately equal to 3.14159265. And just based on the answers, I see they're going out 2 digits. So I'm assuming they just want us to use 3.14. And so we're going to say that 14 pi is approximately equal to 14 multiplied by 3.14. So we'll do that. We'll do 3.14 times 14. 4 times 4 is 16. Carry the 1. 4 times 1 is 4, plus 1 is 5. 3 times 4 is 12. 4 times 1 is 4. 1 times 1 is 1. 3 times 1 is 3. We have 6, 9, 3, 4. And we move over 2 decimal places. And so this would be cubic inches, which we would write as inches cubed. So let's go look at our answers. 43.96. That's what I would choose. Okay. Why didn't I? Look here. They gave you 336 people and then 336 million people. Make sure you choose the right one. Okay, so we did that. Now we're looking at number 5. I'm actually going to show you how long we've been working just to get to the 5th problem. We've been recording for 27 minutes. So we did 4 problems in 27 minutes. 6.75 minutes per problem. 6 minutes and 45 seconds per problem. Yeah, I mean that's fine. It's about double what most students are willing to spend on each problem, and this is one of the reasons why students have trouble. Okay, so it's giving us a linear function here on number 5. G of x equals 1/4 x minus 2. What domain value corresponds to a range value of 1/8? Now this kind of language is just super confusing, and so it's understandable why students just collapse and freak out, when they see this. It's because they're not used to this language. Okay, let's get a couple things down here. When you see domain, just think x. Okay, so don't worry about domain. Which x value corresponds, and then when you see range, don't worry about range. Just think about y. Okay, so read it again, makes a lot more sense. In fact, cancel out g of x and just put y. So now look at this again. Given the linear function y equals 1/4 x minus 2, which x value corresponds to a y value of 1/8? In other words, what is x when y is 1/8? Okay, so let's look at that function again, or the equation. We were given y equals 1/4 x minus 2. And what we're going to do is we're going to substitute 1/8 for y. Okay, so I'm going to write 1/8 equals 1/4 x minus 2. and I'm just going to solve. Now, my first step here would be to add 2 to both sides. But when I'm looking over here, I see that I've got 1/8. And so I need to convert 2 into some number with a base of 8 in the denominator. All right, so you got to think about that. What would you do? Well, I would multiply 2 over 1 times 8 over 8. And that would give me 16 over 8. Just a little side work here. So instead of literally adding 2 to both sides, let's add the equivalent fraction, 16/8 to both sides. Now we know that is 2, so those cancel there. But over here, because I now have common denominators with these 8s, I can add 1 plus 16 and get 17/8 equals 1/4 x. And now I'm going to do the multiply by the reciprocal. So I'll multiply by 4 over 1 on both sides. All this stuff cancels out, and now I've got x all by itself. And so I could multiply 4 times 17 and then attempt to divide by 8. But one quick trick is to notice that I can kind of reduce this 4/8 fraction here. This is 1/2. See that? So what I'm left with now is 17/2. And that's much easier to divide. Okay, by 17 divided by 2. 2 goes into 17 8 times. And that's going to be 16 with the remainder of 1. Remember, put a dot, drop down a 0. And then 2 goes into 10 5 times. So 17/2 is equal to 8.5. And so this is the domain value because domain is x. And I don't know, maybe they want this as a fraction. So 8.5 is 8.5 or 17/2 or 8.5, right? So let's go look at the answer choices and see what they want. They wanted it left in improper fraction form. So that's what I would choose. Here we're asked for the zeros of a cubic. X cubed minus 2x squared minus 9x plus 18. So let's write that down. And I've already forgotten it. X cubed minus 2x squared minus 9x. Okay. X cubed minus 2x squared minus 9x plus 18. Okay, back to that whole thing about the zeros. It's wanting to know what the solutions are. Okay, it's wanting to know what the solutions are. So you can think of zeros and solutions as synonymous. And so we need to set this equal to 0. Now, the good news is the leading coefficient of this cubic is 1. And so what we need to do is start guessing to see if we can guess one of the solutions. All right? So first, let's try 1. Let's see, we got 1 cubed, that's 1, minus 2 times 1 squared, well, that's 1, so minus 2. And then 9 times 1 it's 9, so minus 9 plus 18. And we want to know, does this equal 0? So 1 minus 2 is negative 1. minus 9. Negative 1 minus 9 is negative 10. Negative 10 plus 18 is not equal to 0. So in other words, 1 didn't work, right? That didn't work. So now I would try 2, right? If this doesn't work, I might try negative numbers, but we're going to try 2, okay? So 2, I'm going to write it out. I don't want to confuse anyone. Got 2 cubed minus 2 times 2 squared minus 9 times 2 plus 18. And I want to know, does this equal 0? Okay. Well, 2 times 2 times 2 is 8. And then 2 times 2 squared, that's 4, times 2 is 8. So 8 minus 8. Well, that already cancels out. Negative 9 times 2 is negative 18. Plus 18 does equal 0 because this also cancels out. So you have 0 equals 0. And when you have this condition right here, okay, this means that 2 is a solution. Okay, so that means x equals 2 is a solution. And remember, if x equals 2, then that written as a factor would be x minus 2. Okay, so one of the factors of this cubic is x minus 2. Well, anyway, now that we know that x equals 2 is one of our solutions, we can use synthetic division to find what to do next. So I need to identify these coefficients. The coefficients are the numbers sitting in front of the different letters. Okay, so, and then this isn't a coefficient, this is called a constant. So for synthetic division, I need to write down 1, negative 2, negative 9, positive 18. Okay, and then I'm going to draw a line here. And I'm going to write out here x equals 2. Okay, and then I'm going to draw out another line here. And I'm going to bring down my first number right here. And then what I'm going to do is I'm going to multiply 2 times whatever number is there. And place the product, which is 2, right here. So negative 2 plus 2, that's 0. Now I'm going to multiply 2 times 0, and then place that product right there. Well, 2 times 0 is 0, so put a 0 here. And then 1 plus, or negative 9 plus 0 is negative 9. 2 times negative 9, so I'm going to now multiply 2 times negative 9. That's negative 18. And then these add, right, to be 0. And so we don't even need to write that 0. We just need to now look at these three numbers and put an x squared here plus 0x minus 9. Okay, so we're constructing a quadratic. So this is our quadratic. Is going to be x squared plus 0x minus 9 equals 0. And now we need to factor this quadratic. We're going to just try simple factoring because the leading coefficient is 1. Okay, we can try simple factoring. So I just need two numbers that add to equal the middle term, which in this case the middle coefficient is 0. It's kind of weird, but it still works. And those same two numbers need to multiply to equal this constant term at the end of negative 9. And so a quick thought, if you take negative 9, you got negative 3 and positive 3. Those add to equal 0, but they multiply to equal negative 9. And so those are your factors. Negative 3, positive 3. Negative 3, positive 3. So I'm going to rewrite this standard form quadratic equation in factored form. So that's going to be x minus 3 and x plus 3. I can't remember if this problem asks us for the solutions or the factors, but here are all the factors of this cubic. I want to make sure this is really clear. So our original cubic was x cubed minus 2x squared minus 9x plus 18. So x cubed minus 2x squared minus 9x plus 18 is equal to, remember, one of our solutions was x equals 2, and that factor would be x minus 2. So this is a standard form cubic equation is equal to, here's the factored form, x minus 2 times x minus 3 times x plus 3. Okay, these are equivalent. So if you want to solve the cubic, you just set each of your factors equal to 0. And we see here this is x equals positive 2, x equals positive 3, and x equals negative 3. And we have 3 solutions, 3 roots, 3 zeros. And sure enough, that makes sense because according to the fundamental theorem of algebra, there should be 3 solutions. So that means that this cubic equation crosses the x-axis in 3 places. It crosses at positive 2 right here, at positive 3 right here, and at negative 3 right here. And I don't know what it would look like. I'm just saying that that's what that means. Okay? So 2, 3, and negative 3. That's what I would pick. Okay, let's take a look at number 7. Okay, so it's asking us for an equivalent expression to this one. Let me go ahead and grab it. Okay, so there's often a gap in students learning about how to actually rewrite these radical signs. So I want to do a quick little tutorial about that. When I've got a radical sign, okay, that's what this is. It's a radical sign. There is an index value here. So we call it an index. And usually we denote that index as n. And then there's some number or something in here raised to some exponent. Yep. We call that exponent m. Okay, so let's look at an example. If n equals 3, and I've got a raised to the power of 2, then we write this as a raised to the power of m over n. Okay, so that's equivalent to this radical expression. So in here, the 2 is the m and the 3 is the n. So I could rewrite this as a raised to the power of 2/3. So let's look at our example. We have the 4th root. I'm looking here at this. I've got the 4th root of x raised to the power of 6. So the 4 is the n, the index, and the 6 is the m, or the exponent. So I can rewrite this as x to the 6/4 power. Okay, so let's try that. Let's do that. We have x to the power of 6/4 minus x over x cubed plus x minus 2. Now I want to focus our attention here. We have a rule called the quotient rule. So if I have x to the 1st power over x to the 3rd power, the quotient rule, or the division rule for exponents, tells me I subtract the exponents like that. So this is going to give me x to the power of -2. So that was the division rule. Now we have x raised to the power of a negative number. So we need to use the negative exponent rule. And what that tells us is that if I have x to the power of -2, I can rewrite that as 1 over x raised to the positive power of 2. So these are equivalent to each other. So I've now reduced this and changed this to 1 over x squared, basically. And so I'm going to continue rewriting this. I have x to the 6/4 power minus 1 over x squared plus x minus 2. Now, I don't know if they want us to do anything more with that. Okay, I see. There's just one thing they want us to do. They want us to reduce this fraction. So 6/4 I can divide by 2, and that will give me 3/2. So in final form, they want us to do x raised to the power of 3/2 minus 1 over x squared plus x minus 2. So it looks like this whole business here about how to rewrite a radical sign without the radical sign, and then using the division rule for exponents, and then applying that negative exponent rule. This is kind of the point of this problem. And so that would give me this one. That's what I would choose right there. Okay, in this problem on number 8, we're asked to find the equation of a line passing through 2 points, -3, 7, and -1, -5. So our points are -3, 7, and -1, -5. common pitfall for students here is they have to remember a couple of things. First step in finding the equation of a line is to find the slope. And when you're only given 2 points, you have to use the slope formula. So slope, which we call m, is equal to y2 minus y1 over x2 minus x1. And so now that I've started to introduce these letters, I need to label x1, y1, x2, y2. And so I can kind of plug the numbers in now over here. So my slope m is going to be equal to y2, which is negative 5, minus y1, which is 7, over x2, which is negative 1, minus x1, which is negative 3. Be careful there, I've got a double negative. That becomes a plus sign. So let's further simplify. Negative 5 minus 7 is negative 12, over negative 1 plus 3 is positive 2. So m equals negative 6. Okay, so I've got the slope. Now I need to recall a form called the point slope form. Okay. And that form is y minus y1 equals m, open parentheses, x minus x1, close parentheses. We're just going to substitute in values here. I've got y minus y1, which is 7, equals m, which we already found to be negative 6, open parentheses, x minus x1, so that's x minus negative 3. And this will become a plus. So I have y minus 7. And what I'm going to do now is distribute that negative 6 through the parentheses. This is going to give me negative 6x. And then negative 6 times 3 is negative 18. So now I add 7 to both sides. So y will equal negative 6x. And then negative 18 plus 7 is negative 11. And that's the equation, negative 6x minus 11. Here we're being asked to find the equation of a vertical line that runs through the point 1, 4. Okay. So this is a question that's trying to assess whether the student understands that this is the x value and this is the y value, and that when we're talking about equations of vertical lines, all equations of vertical lines start with x equals. Okay, so the only information we're given is that x equals 1. And that's the answer. X equals 1. Okay, so in this instance, we don't care about the y value at all. Here we're being asked to find the area of a rectangle. That's just length times width. 9 times 4 is 36. And we have to be careful because It's not 36 centimeters because we're finding the area. That's a square measurement. So 36 centimeters squared is the appropriate answer there. Okay, now I take issue with this question. They seem to be just substituting in numbers here. Instead of asking us what the formula for the area of a cylinder is, or instead of giving us a cylinder with some measurements and asking us for the surface area, they're just sort of presenting these possible answers. And I guess we have to kind of backtrack and figure out what they're doing. I don't like the question. It's confusing. But let's just get out of that for a minute and just go back to our scratch paper and just draw a cylinder. Okay, so this isn't an art class and I'm no artist. But, here's a cylinder, right? And so the way I like to think about it is there are two circles there, right? So if I find the area of those two circles, and then I just multiply by the height, I'll have the total surface area of the whole cylinder. So you think about it, these areas will be the same. So I can write that as 2 times the area of the circle times the height. Now, area of a circle is equal to pi r squared. Okay, so that if I'm going to substitute this form in here, this would be 2 times pi times r squared times the height. So we have to go back and try to use this and see what they're doing, right? So here in this C value, I see 2 times pi times 5 squared. So that looks like 2 pi r squared, but they're not multiplying by the height. Here I see 2 times, I'm assuming the 5 is the radius, 2 times pi r squared. That's good. But then this 2 pi times 5 times 10, none of this makes any sense to me at all. If 5 is in fact the area, this doesn't make sense either. 2 pi times 10 times pi r squared, this doesn't make sense to me either. So I am stumped on this question. I'm completely stumped, so I'm going to review it. I don't know what is being asked. I wonder if there's a picture that's supposed to go with this that I'm missing that didn't load, but it looks like an error to me. I'm interested to see what the answer is, but I can't make heads or tails of it. Okay, now this is an inequality problem, and it's just a little confusing when you read it. So let's grab this and work on it a little bit. Can make it easy. Okay, so we've got Aaron and Katie, and they're working. It says together they work less than 21 hours a week. So we can go ahead and write down less than 21. It says in a week, if Katie worked 2 times as many hours as Aaron, how many hours did Aaron work? And so what they want us to do is they want us to rewrite the word Katie in terms of Aaron, right? So you can think about it like this. Katie equals 2 times Aaron, right? So Katie equals 2 times the number of hours Aaron worked. So if we call Aaron E, then Katie equals 2E. So the equation or the inequality would be Katie, which is 2E, plus E, which is just Aaron, is less than 21. So this is Katie, and this is Aaron. Okay, so we just add 2E to 1E, and we have 3E is less than 21. Remember, it wants to know how many hours Aaron worked, so we would just divide both sides by 3. And we have that Aaron worked less than 7 hours. Okay. Okay, here in this problem, number 13, we're asked to find the solution to this equation. That's 3 and then x plus 2, 14x minus 5. It was 3 and then x plus 2 equals 14x minus 5. Okay, just let me double check it again. Okay, so we just have to solve this. Sometimes it helps students to put a vertical line here just to keep their equal sign lined up. We need to distribute the 3 into the binomial. So this 3 times x is 3x, and 3 times 2 is 6, so plus 6 equals 14x minus 5. Now I want to gather my x's together, so I'll subtract 14x from both sides. And 3 minus 14 is negative 11x plus 6 equals negative 5. Now I'll subtract 6 from both sides. This is negative 11x equals negative 11. And I'll divide both sides now by the coefficient of the x variable, which is negative 11. So x equals positive 1. We have another equation here. 10 minus 5x plus 2. Seven x plus 12 minus 12x. Okay. So once again, we can put this here. Now, the first thing to do is to combine like terms. So I can combine the 10 and the 2. That would be 12 minus 5x equals, and then over here I've got the 7x and the negative 12x. So that will give me 12, and then negative 12x and 7x come together to be negative 5x. So I'll subtract the 12s out. And I have a unique situation here. Negative 5x equals negative 5x. Let's go ahead and carry this out to its conclusion here. If I divide both sides by negative 5, I see that I have x equals x. So in this situation, if I were to keep going, right, I would subtract x from both sides. And then I'd have 0 equals 0. And the question is, what's going on? So what this means, when you see this, you need to be aware. This means that there are an infinite number of solutions. Okay, so all real numbers would be the correct choice there. Okay, we're on number 15, and we're asked to solve this equation. So I'll just clip it. All right, so we're going to solve this equation. First, I'm going to distribute the 4, and then I'm going to distribute the 2. 4 times x is 4x. 4 times 5, that's going to be plus 20. Plus 6 equals 2 times 2x is 4x. Plus 2 times 3, that's going to be plus 6. Over here, I can combine these like terms. So I have 4x plus 26 equals 4x plus 6. We got a problem brewing here, but I'll show you. So now we're gonna subtract 4x from both sides, and you see that we've eliminated the x altogether, and so we have a question here. 26 equals 6. This is false. So when you come to a situation like this, 26 does not equal 6. Therefore, there is no solution. Okay, now this whole business about 2 consecutive integers, this is a problem type that we don't really teach well. So it's difficult to figure it out. It looks really hard, but it isn't. So we just have to know how to write 2 consecutive integers. Okay. So when we say 2 consecutive integers, I want us to think about the numbers, 3 and 4. Okay. Let's think about 3 as n. And so what would I do to n to make it be 4? Well, I would do n, if n is 3, then 4 would just be equal to n plus 1, right? Because n is 3. So the way you think about this when you talk about consecutive integers, your first integer is n, and then you're going to say plus, and then you have n plus 1. Okay. And so what it's saying is the sum of 3 times the first and 2 less than the second is equal to 411. So this is going to be 3 times n plus 2 less than the second. So it's going to be 3n plus, open parentheses, n minus 2 less than the second. That's going to be n plus 1 minus 2. Remember that second integer is n plus 1. And that's going to equal 411. So just don't lose sight of the fact that it's n and then n plus 1. So 3 times the first would be 3 times n. And then it says 2 less than the second. Well, the second is n plus 1. So if I take n plus 1 and I subtract 2, that's 2 less than the second. So let's just write this out. It's going to be 3n plus n, and then 1 minus 2. Well, I'll write it all out. Plus 1 minus 2 equals 411. Okay. So I can combine these terms and these terms. So 3n plus n is going to be 4n. Remember, there's a 1 here. And then 1 minus 2 is negative 1. So 4n minus 1 equals 411. So now I'm going to add 1 to both sides. 4n equals 412. If I divide both sides by 4, n will equal 103, right? Because 103 times 4 is going to give me 412. Okay? So that's your answer right there. It wants to know what the integers were. So if n, remember it's n and then n plus 1. So if n is 103, then n plus 1 is 104. So it's 103 and 104. Okay. Okay, here in this problem, men are the lighter color. From what I can see, it's kind of actually hard to tell. Women are the darker color. And then it says which two are preferred by more men than women. So I'm just saying, well, comedy and action are preferred by the lighter color more. Okay, so I would choose that one. All right, this question here, what type of graph best represents continuous change over time? And bar graphs, pie graphs, and histograms don't show linear or any kind of progression over time. It doesn't have to be linear. but it doesn't, they don't show movement over time. It's line graphs that show changes over time. Which of the following relations is a function? So here we want to look for repeating x's. If the x's repeat, it's not a function. It's okay for the y's to repeat. So here I see the 1's repeat, so that's not a function. Here I don't see that any of the x values repeat, so that's a function. Here I notice that the 1's repeat here and here, and then here the 1's repeat, so this is the only relation that's also a function. Here it wants us to evaluate this function, x squared minus 2x plus 1 at 5. So let's go x squared minus 2x plus 1. So we're given f of x equals x squared minus 2x plus 1. So we want to evaluate f of 5. So that's going to equal 5 squared minus 2 times 5 plus 1. 5 squared is 25. 2 times 5 is 10 plus 1. So left to right, this is going to be 15 plus 1. So f of 5 equals 16. For this problem here, the only thing you need to be aware of is that this is a quadratic function. The domain of all quadratic functions is infinite, all real numbers. So the range is not all real numbers, but the domain is all real numbers. Negative infinity to positive infinity, all real numbers. Now here it's asking us for the range. In the last problem, we were asked for the domain. The domain's easy. If it's quadratic, it's all real numbers. But range is different. Range requires some work. So f of x equals 2x squared plus 5. Okay, so we're going to go here and write f of x equals 2x squared plus 5. Okay, so here's the thing. Quadratic functions are typically written f of x equals ax squared plus bx plus c. This is called the quadratic term. This is called the linear term. And this is called the constant. Notice that the linear term is missing, okay, from here. It's missing. So it's actually 0. So if you wanted to rewrite this, you could write 2x squared plus 0x plus 5. And what this means is there is no shift horizontally from the y-axis. So you can look at this like the way this graph looks is it's going to be centered on the y-axis. And this term, the constant term, this is the y-intercept. So 5 is the y-int. 1, 2, 3, 4, 5. it's got a positive leading coefficient, which means it points up. So the graph looks like this. In other words, the lowest point on this graph is 5. So, and that it's inclusive. So the way you would write the range using this notation would be open bracket. That means it contains the number 5, and then it goes up until infinity. So this is your range right here. So here we're given two equations, and we're asked to find two values of x for this. So what I think we should do is set these two equations equal to one another, and then get all the terms on one side, and then factor that quadratic. That's my plan of action. Let me just grab it. Okay, so we're going to write this like this. 4x plus 4 equals x squared plus 3x plus 2. I'm going to try to get these terms to go away. So I'm going to subtract 4x from both sides. Now I have 4 equals x squared. This is minus x plus 2. And then I'll subtract 4. So now I have 0, which is what I want, equals x squared minus x minus 2. Now I want to factor this quadratic right here. So I need two numbers that add to equal -1. That's that middle term. And those same two numbers need to multiply to equal -2. And so I'm thinking, let me think about it for a minute. If I take -2 and break it down, I got, can do 1 and -2. Can do -1 and +2. And so the sum, these both multiply to be -2, but this one adds to be -1, and this one adds to be +1. So we would discard this. These are my two factors, 1 and -2, 1 and -2. They satisfy both these conditions. So I'm going to rewrite this in factored form as x plus 1 times x minus 2. Now I'm going to set both my factors equal to 0. So x equals -1 and x equals +2. So -1 and +2 right there. Okay, here we're on number 24. It's talking about coyotes. So we're going to grab this problem. We need to chop it up. Okay, it says here the population of coyotes has been falling since 2000. The population can be modeled by this function, where y represents the number of coyotes and x represents the number of years past 2000. When will there be no more coyotes? So the key phrase here is y is the coyotes. So the question is, when will there be 0 coyotes? So we need to write this equation down. Okay, y equals negative, open parentheses, x minus 2 squared plus 1600. We need to reinterpret this y to be f of x. Okay, and so it wants to know, what about when this whole thing is 0? Okay, so write 0 equals negative, open parentheses, x minus 2, close parentheses, squared, plus 1,600. So this is basically asking us to solve a quadratic equation. So we leave this negative alone, and we're going to just focus over here in side work on expanding x minus 2 squared. So remember, that's equal to x minus 2 times x minus 2. We can use FOIL. First, outer, inner, last. X squared minus 2x minus 2x plus 4. It's x squared minus 4x plus 4. And for so what we'll do now is we'll go back here and substitute that back in. It's going to be negative, open parentheses, x squared minus 4x plus 4 plus 1600. Distribute the negative. So you'll have negative x squared plus 4x minus 4 plus 1600. Now we can add these together. So we have negative x squared plus 4x and negative 4 plus 1600 would be positive 1,596. Now we just have to factor this quadratic. So because the leading coefficient is -1, there are many ways to do this. I'll show this by using the quadratic equation. X equals -b plus or minus the square root of b squared minus 4ac, all divided by 2a. Okay. And so here we'll plug in our numbers. -1 is a, b is 4, c is 1596. So negative b would be -4 plus or minus the square root of b squared. So that's -4 squared minus 4 times a, which was -1, times b, which is times c, which is 1,596. all divided by 2 times a, which is -1. So -4 plus or minus the square root. -4 squared is positive 16 minus, now be careful, you got to do all this multiplication first. So 1596 times -1 is -1596, but we need to multiply that by 4. So 1596 times 4. Hold on. Getting tired. So back up. It's 24, and then 36, 37. Carry the 3. So yeah, that's 23, and then 6. Okay. So that's 6,374. We're going to end up with a negative root. So something went wrong here. Okay, let me back up here. I think I got sidetracked and made a mistake. Let's go back to where we figured out that this was going to be x minus 2 times x minus 2. And then I foiled it out. But let's say that I didn't foil it out. And instead, I'm just going to substitute in this factored expression back into the equation. Okay, so let me just move past this and sort of bring this all the way down here. And so I've got negative, so I'll just write 0 equals negative, and then I've got x minus 2 times x minus 2. We'll put that in parentheses here for a sec. And then plus 1600. Now let's say I subtract 1600 from both sides. Okay. Now I've got negative 1600 equals negative, and then this whole thing, x minus 2, and then x minus 2. And then what if I divide out a -1 here on both sides? That'll take care of these. So now I'll have 1600 equals x minus 2 squared, right? That's what we had before, x minus 2 squared. So all I need to do is take the square root of both of these. So hopefully 1600 has a square root, like maybe it's 40 times 40. So that's going to be 40 equals x minus 2. Add 2 to both sides. And I get x equals 42. So I need to add 42 to 2,000. So 2,042. Sorry about that. I'm getting kind of tired. It's we've been going at this for an hour and 35 minutes, and it's 11:48 p.m. My apologies. Okay, number 25. A ball is thrown up from a building that's 800 feet high. Its position can be modeled by this equation. And it wants to know how long will it take for the ball to come back to its starting point. I see. A ball is thrown up from a building that's 800 feet high. All right, so let's just draw the building here. It's 800 feet high. You got a guy up here throwing a ball up, right? It's going up. And we want to know how long it will take for it to come back down from where it started. So let's assume the guy just throws the ball straight up in the air. It's going to make some kind of an arc and then come back down, right? So what it's really looking for is that we solve the quadratic. Negative 32 t squared plus 90t plus 800. Got negative 32 t squared plus 90t plus 800. My computer is freezing up on me. I'm going to have to pause and start a new video.